chunks out of me. You're a shark and I'm swimming. My heart still thumps as I bleed. And all your friends come sniffing.
Okay, chapter 2 is on geometry, and the first section is actually called geometry. And this is something we're definitely going to do in class, so if you miss class or something, here you go. But I'm going to skip some things because I would have covered them in class. Anyway, let's start on actually the second example. I don't know why I did them in this order. Basically what you're trying to do in all these questions is to figure out the missing angles, and in this one you're trying to find x, y, and z, but we could find all the angles here. There's a whole bunch of angles here, right? There's also an angle here we could find, an angle here we could find, here and here, so let's find all of them. Now these lines, you have parallel lines here. Actually I don't have it represented, but these are parallel lines, and I'll put this symbol to show they're parallel. And if you have parallel lines and then another line that crosses them, this line here is crossing them, right? This line is called the transversal. And when you get that transversal, you get a whole bunch of angles showing up. You get 8 of them. 1, 2, then x and 58 are 3 and 4, y and z are 5 and 6, and then 7, 8 down here. So you get 8 angles. And there's all sorts of relationships. And this is a thing I'm going to kind of breeze over here, but I'll spend more time in class talking about. Anyway, if I know this is 58 and that's the only thing I know, and I want to find all these other angles, there's all sorts of ways you could actually do it. Let's start by finding this angle right here. Well, if this one's 58 and this one's right across from it, those are called vertical angles, or vertically opposite angles, and they're exactly the same. So this is 58 degrees. Okay, how about if we know this original 58 and we want to find the x? Well, what you can do for that one is, if you look, you have this angle, the 58, plus that angle, the x. And do you see how it makes a half circle? So how many degrees are in a half circle? Well, there's 360 in the full circle, so there's 180 in half a circle. So the x plus the 58 has to equal 180. Sorry. So I guess I could write that down if you want. X plus 58 degrees has to equal 180. So the way you'd solve it, obviously, subtract 58 from both sides. You do 180, take away 58, and if you do that, you'll get x equals 122 degrees. So that's how much this one is here. X is 122 degrees. Okay, how could you get this one up here, this black one? Well, there's 3 ways you could do it. You could do the half circle thing again with the 58, you could do the half circle thing again with this 58, or you could do the vertically opposite angles with the x. This is across from the x, so this is 122 degrees. By the way, when 2 angles add up to 180, like the 58 and the 122 here, we call them supplementary angles. Alright, so now how are we going to figure out? We have to figure out one of the angles down here based on one of the angles up there. And there's all sorts of ways you could do that as well. So there's pretty much 3 basic ways you could do that. One way you could do it is you could make a Z, I call it, and using the transversal as the backbone of the Z. And in the armpits of the Z, so here's one armpit and here's one armpit there, they're going to be equal to each other. That's called alternate interior angles, and they're the same. So you know that this angle y down here is 58 degrees. And now, of course, you could figure this angle out because they're vertically opposite. You could figure z out because it's half a circle, and you could figure this one here because it's half a circle as well. But let's just pretend we didn't know that, or just let me show you another way you could find some of these other angles. Okay, the way you could use this 58 up here, so I'm doing everything with this 58 here, the way I could find this angle down here is they're kind of in the same position. If you look up here in this parallel line, the 58's in the bottom right hand angle, right? Well, same down here. Here's the bottom right hand angle. So these are called corresponding angles, and corresponding angles are also equal to each other. So this is going to be 58 degrees right here. Okay, again, let's use this highlighted angle here to figure out Z. Now, the letter that you would draw here is you could draw a C. And the angles inside the C are called interior angles, and they're not equal to each other, they're supplementary. In other words, they add to 180. So 58 plus something equals 180. Hey, we did that over here. It equals 122 degrees. And you could have also, I'll just write that in there, 122 degrees. You could have also figured that out with the x, because you could draw that right way around Z this time. I guess the other one was backwards, wasn't it? And you'd have armpit, armpit, and so those are equal to each other. Last one is this one. There's about 8 different ways you could do it. The easiest way is probably the opposite angles, vertically opposite angles. It's opposite from 122, so this angle here is 122. These are the most basic ones. Hopefully you understood all that, because those are the most basic ones you need to know. Okay, let's move back up to this one now and figure out some of these angles. So if you look at this, there's a whole bunch of triangles, but there's one big triangle in here. And in the big triangle, we have this right here. You know that means 90 degrees. And we have 74 degrees here. So can you see that we should be able to get this angle right there, no problem? How come? Because angles in a triangle add up to 180. So in other words, to get this angle right here, what you could do is 180, take away the 90, and take away the 74. And whatever that equals, that's how much this will be right there. And what that equals is 16 degrees. Okay, next thing. You see these tick marks? Those tick marks mean that these sides are equal to each other. So this side from here to here is equal to this side from here to here. This means it's a nice isosceles triangle there. Two sides are the same. If there's two sides the same, there's also two angles the same. Now, which angles are the same? The ones that are across from the corresponding, from the congruent sides. So this angle is across from this side, and this angle up here is across from this side, so this one's also 16 degrees. Next, you'd probably get this. How can you get that? Well, if you look at this small triangle, you know two of the angles, 16 and 16, so you could do this one by going 180, take away 16, take away 16, because they all have to add up to 180, and if you do that, you get 148 degrees. So this is 148 degrees. Okay, what could you do next? Well, you could get, I'll use a different color, you could get this angle next. Look at, you have the half circle here. So 148 plus something has to equal 180, and it's 32 degrees. So you know that this is 32 degrees. Next, you could get this one. How come? Because we have another isosceles triangle in here. This angle is across from that side. This angle is across from that side. So since those sides are the same, so are the angles. This is 32 degrees. Next, you could get this angle. How come? Because in the small triangle, you know two angles, and all three of them add to 180. So to get this one here, you could go 180 minus 32 minus 32, and if you do that, you'll get 116 degrees. Okay, what do you want to do next? I guess we could do, I'll use another color, you could use this one. We have a half circle here, so the whole thing equals 180. Take away 32 equals 148. And what's left? Just this amount here. How could you get that? Well, there's two ways you could do this, at least two ways. One way is that you could just look at this shape here, this four-sided shape. It's called a quadrilateral, right? Any four-sided shape, four-sided polygon is called a quadrilateral. And in a quadrilateral, all the sides add up to, all the angles add up to 360. So you could do it that way. 360, take away 74, take away 90, take away 148. Or the other way you could do it is you could look at this angle, this 16 degrees, plus the 116 degrees, plus this degree, plus this angle here. And do you see that makes a half circle? In other words, 180, take away the 16, take away the 116. If you were to do that, you also be left with what this angle must be equal to there. And if you do that, you should get 48 degrees. So this right here is 48 degrees. Alright, hopefully this is reminding you, this stuff especially up here is reminding you of some stuff you've done before. You might not have encountered this before, but it's not too bad. Once you've seen one of this type, you'll probably get them all, no problem. So you've got three angles here, but they have x's in it. It's kind of weird. But what do you know about the three angles in a triangle? You know they add up to 180. So in other words, this angle, which is 3x, plus this angle, which is 4x plus 10, plus this angle, which is 4x plus 5, if you add all those together, you're going to get 180. So you just have a fairly simple algebraic question to answer. You can combine the x's. 3x plus 4x plus 4x is 11x. You can combine the 10 and the 5 to get plus 15. equals 180, and subtract 15 from both sides, you get 11x equals 165. If you divide by 11 on both sides, 11 goes in evenly actually, it's 15 degrees. So if the questions ask you for what are the angles though, don't stop. None of the angles are 15 degrees, are they? No, this angle here is 3 times x, so it's 3 times 15. This angle is 45 degrees right here. This angle here is 4 times x, which is 15, plus 5. So that's 60 plus 5, it's 65 degrees. And this one here is 4 times x, which is 15, plus another 10. So that's 4 times 5 is 60, plus another 10 is 70 degrees, this one. Okay, kind of more of the same here. Probably don't even need to do all these examples. I don't know, you probably need to start in this triangle. And you know this is a 90-degree angle, and now you have 2 in this triangle, so you should be able to get the third one. 180 minus 90 minus 65 is 25 degrees. Okay, do you see which angle you're going to have to get next? There's an angle that's vertically opposite to this A. Look at the lines that make up A. This line and this line. Hey, those also make up B. So B is vertically opposite from A, so this is 25 degrees as well. Now if we look down here at this triangle, you know 2 of the angles, 25 and 75, which add to 100. We must need another 80 to get to add to 180. What next? How about a half circle here? So if this is 75, how much more do you need here to get to be 180? You need this bit right here to be 105, so that the half circle is 180. Now if you look at the triangle up here, you know 2 angles, 105 and 38. So you could do 180 minus 105 minus 38 to get the other angle. And this equals 37 degrees. So this is 37 degrees here. Now to get F, you could make a half circle. You can do it in one of 2 places. You can either make the half circle there, or, and it's exactly the same thing, you can make the half circle there. Same thing, because 25 here rather than 25 there. Anyway, to get F here, you're obviously doing 180, take away 37, take away 25, and what you'll find is this amount in here is 118 degrees, and we got them all. Okay, last one I'll show you is this one. It's important because it involves circles. Now, I know this is terrible. This is supposed to be the center. Okay, yes, I know, fail, Mr. Waj, but can you just pretend that's the center of the circle? We have to know that's the center. Or it has to be the center of the circle, otherwise we can't answer this. But just pretend that's the center of the circle. Ignore my terrible drawing. This is the center of the circle. Now, whenever you have circles, and you know, and it goes to the center of the circle, you have a bunch of radiuses, or radii, popping up. And that's good news, because what do you know about the length of every radius? They're all the same in a circle. So there's a radius, for example, that goes from the red dot, the center, out to here, right there. There's another radius that goes from the red dot out this way. And there's another radius that goes from the center out here. These are all the same side lengths. So if you look at this triangle up here, this is an isosceles triangle. 2 of the sides are the same, this one and this one, which means 2 of the angles are the same. Which angles are the same? This one, because it's across from that side, and this one, which is across from that side. So if we know this one's 50, and we know these 2 are equal to each other, that's how I show they're equal to each other, how do I do this? Well, I can go 180, take away 50, equals 130. These 2 together have to equal 130. But they're exactly the same as each other. So if I divide it by 2, I'll find that they're both 65 degrees. Alright, now I need to find an angle in this triangle. Do you see which one we can find? This one right here, because of the half circle. If this is 50, then 180 minus the 50 is 130. And then we have another isosceles triangle over here. We have 2 sides the same, so it means we have 2 angles the same. Which angles? This one up here, which is across from that side, and this one down here, which is across from this side. They have to be the same. So if this is 130, then 180 minus the 130 leaves you with 50 degrees. And these 2 together have to equal 50 degrees. So divide it by 2 and you get 25 degrees here. This is 25 degrees and this is 25 degrees. And I think that's all of them. Okay, we're finished. That's the sort of thing you need to be able to do in this section.
Triangles are my favorite shape. 3 points where 2 lines meet. Toe to toe, back to back, let's go. My love, it's very late. Till morning comes. desolate.